an effort to reduce greenhouse gases, we've seen a rise in the variety of alternative fuels available in the marketplace. Of course, natural gas remains the dominant fuel in heating, cooking, transportation, materials and plastics, and most importantly, keeping the lights on, totaling nearly 30 trillion cubic feet of fuel consumed annually in the United States alone, according to the U.S. Department of Energy. Despite the tremendous dependency on natural gas, it remains a significant carbon emitter of GHG. From the extraction method like fracking to its use is still a pollutant to the environment. The need for a lower carbon option has inspired a growth in alternative fuels, including the likes of biodiesel, bioalcohol, refuse-derived fuel, chemically stored electricity like batteries and fuel cells, hydrogen, non-fossil methane, non-fossil natural gas, vegetable oil, propane, and other biomass sources. Hydrogen, in particular what is known as green hydrogen, has been discussed as a potential exciting solution, though much development is still needed, and as a fuel it remains elusive in the marketplace. Here to discuss another alternative fuel, as well as other topics, all the way from Bath, England, is John Armstrong, head of City Energy at a company called E.ON. John Armstrong, welcome to Energy Central's Power Perspectives podcast.
Thanks, Jason. It's a real pleasure and honor to be invited to do a podcast with Energy Central.
I also want to welcome my colleague based in Orlando, Florida, Matt Chester, community manager at Energy Central and producer of the Power Perspective podcast. And I'm your host, Jason Price of West Monroe in the energy and utility practice in New York City. Like I mentioned, John is head of City Energy for E.ON, a 70,000-strong German-based energy developer and provider. While he oversees projects in the UK, John has been a member of Energy Central since early 2019 and has already accumulated over 18,000 views of his content on the platform. John, before we dig into the popular article you published on Energy Central about that other green energy alternative called ammonia, please share with us background of how you ended up at E.ON.
I actually started out with an American company, Kellogg Brown & Root, building gas refineries. And after a period abroad building a couple of gas processing facilities, I wanted to come closer to home. And so I joined E.ON as an engineer in the power stations. Since then, I've worked across generation on conventional gas power stations, coal power stations, renewables, a little bit of wind. And then more recently, I've been building a team to develop and operate district heating and decentralized energy systems across the UK, growing a district heating business from a tiny team of 12 engineers with 5,000 residential customers to today where we're nearly at 40,000 with a much bigger team than that right across the country.
Terrific. Let's pivot to your article on green ammonia. The article titled, "Could Dirty Ammonia Be the Clean Fuel of the Future?" It appeared on Energy Central on March 25th and quickly became one of the most read articles for the month. Let me ask you this. Is ammonia the new hydrogen?
I think that's a great question, Jason. I think ammonia isn't necessarily the new hydrogen. I think ammonia is something which comes on the side of a hydrogen economy to do the things that hydrogen can't necessarily do, to do the places, to do the jobs that hydrogen hasn't quite got the grit or the energy to really do. So if you think about, for example, heavy haulage or heavy rail, where you need an awful lot of power to move something, ammonia has the potential to give engines some real grunt to move that kind of heavy load. Really importantly, whereas hydrogen, you get a good energy density with hydrogen, but you have to cool it into a liquid or compress it to super high pressures. So hydrogen, you need to cool it to minus 252 degrees Celsius or minus 423 degrees Fahrenheit. With ammonia, you only have to go down to about minus 33 Celsius, minus 28 Fahrenheit. So it takes a lot less energy to get it into that compressed state. So I don't think we'll see ammonia being piped into people's houses to replace gas boilers, but I do think we might see some applications on the side of a hydrogen economy where ammonia provides a much better option for certain applications. Currently, there's a lot of work being done around shipping, looking at ammonia as a fuel. It's an interesting technology. It's not an answer. It's not a clear answer to a problem, but it forms part of the patchwork of solutions that we'll see as the new energy world emerges. What I do want to be clear, though, is when we're talking about hydrogen and ammonia, what we're talking about is ways of moving energy around and storing energy. Ammonia and hydrogen are not in themselves green. And I think that's a real challenge for industry, in that often when we talk about hydrogen, people talk about hydrogen being green. Hydrogen in itself is not green. What's the green is how you go about making the hydrogen. Hydrogen is just a vector for moving energy around, just as ammonia is. And ammonia is just giving you an alternative vector with some different chemical properties that may work in certain applications. So is ammonia the new hydrogen? I don't think so. I think ammonia is something that complements hydrogen and helps a hydrogen economy grow.
John, can you speak to some of the main challenges of ammonia? In hydrogen, you mentioned one of the common ones is separating green hydrogen versus not so green hydrogen, and how that's similar in ammonia. Does ammonia have some of the other notable challenges that people would bring up with hydrogen, whether that's high cost of generation and storage or the amount of R&D still needed? Are those typical hurdles discussed with hydrogen the same ones for ammonia, or are there some unique ammonia hurdles to overcome?
I think, it's a great question, because with ammonia, you have to make hydrogen first. So the way you make ammonia is you take hydrogen and you combine it with nitrogen through a process called the Haber-Bosch process. And at the back end, you get ammonia. And actually, the world is pretty experienced at making ammonia. Globally, the ammonia market is worth about $33 billion currently, and that pretty much follows that process. So I think actually when we talk about ammonia and hydrogen, it's really important to point out that you get the different flavors of hydrogen. So you get the green hydrogen from renewables, ranging through to the black hydrogen, which is basically used what's called steam reformation of methane, where you throw steam at natural gas in a hugely carbon intensive process to spin off the hydrogen molecules. So you've already got, with ammonia, you've already got the challenges that you have with hydrogen. On top of it, you've also got some really fun stuff, because ammonia in itself is quite a challenging gas to transport, to use, to ship. So exposure to high concentrations of ammonia causes a burning of the eyes, nose and throat, amongst other things. So it's not particularly a pleasant fuel. That said, we already have a lot of experience of handling it. There's already pipelines in the States. And if you look at applications like cooling, heat pumps, fertilizer, people are well used to handling ammonia. I don't think we'd ever get to a place where we'd be putting ammonia into people's homes, piping it in. I think that sounds a bit extreme. But I think where you've got those applications where you can handle it safely, it has some options. But as I said, I think your point about the different types of hydrogen, different types of ammonia is a really important one. Again, it's a vector. It's not a solution in itself to green energy. Hydrogen and ammonia are all about how do you take energy from one location to another and use it in a way that's actually useful. So the big aspiration with both hydrogen and ammonia is that you can use wind and solar to generate hydrogen that you can then pipe around. Similarly, you could use wind and solar to generate hydrogen to make ammonia. The challenge, though, is huge. One of the numbers I saw recently from Boston Consulting Group I thought was a really excellent one, highlighting the challenge of hydrogen, was that if you, to decarbonize the current global consumption of hydrogen, would take the entire renewable capacity of Europe as it stands today. And that would be just to tackle the hydrogen we make now. So it would take huge amounts of investment to actually put enough completely green generation in place to be able to get you that green hydrogen and hence green ammonia. I think we may see carbon capture and storage coming in the middle. That's where you get into your blue and brown hydrogen and blue and brown ammonia. And that's where you either through steam reformation, where you do the thing with blasting steam at the methane and then spinning off hydrogen molecules, or various other ways of doing it. But ultimately, you end up with a load of carbon dioxide that you need to pretty much bury deep underground in the carbon and capture and storage scenario. The key, again, is it is not green in itself. It's just a way of shifting energy around. Ammonia, though, does come with some quite fun challenges, doesn't it? But engineers have tackled similar things before. I don't think it's anything new. I think if you were to drive around a big city now, you'll find most large buildings will have a large amount of ammonia. A lot of modern cooling plant is driven by ammonia cooling. So it's not uncommon to see ammonia being used and shipped around.
John, you mentioned shipping as one of the users of green ammonia. Can you talk more about what industries this would be applicable for and what parts of the world you would expect to see perhaps quicker adoption of ammonia, as well as, just general future prognostication of the direction of ammonia in both industrial as well as in products and transportation?
Yeah, I think going back to that discussion around ammonia being almost a bolt-on on the edge of a hydrogen economy. So I think you need to look at where in the world hydrogen and investment in hydrogen is happening very, very quickly. So there's a couple of regions in the UK where there's some real credible projects for putting in hydrogen networks. And Australia are putting a lot of focus on hydrogen, and as are Germany. So there's a number of countries where you start to see real move towards hydrogen as a potential fuel. I think over time then, some of the limitations of hydrogen will become apparent in those applications, and you'll start to see alternative fuels such as ammonia needing to be looked at for those sorts of applications. I think one of the biggest early adopters actually for something like ammonia would be in storage, because it's a really good way of taking hydrogen fuel and storing it, because you can convert it to ammonia relatively easily. The process isn't a particularly complex one. And ammonia is just a lot more easy to store than hydrogen if you need to store a lot of energy in one place. So I think years-wise, we're talking 5 to 10 years out before you'd see anything at scale, and you'd need to see hydrogen developing first. But it's definitely there. It's probably still potentially, I'd say, a black swan technology, but it's got some options to it.
Interesting. So the future of ammonia is really dependent on the future of hydrogen.
Yeah, I wouldn't see it existing separately, because you've got to make the hydrogen first to make ammonia. So I think I would see it coming with hydrogen. I think shipping is probably one of the areas where it does have, if you think about some of those safety challenges, actually in shipping you don't particularly necessarily have that concern. So they're well used in the shipping industry to handling difficult liquid products. So actually you could see in shipping it being a relatively easy move towards some kind of ammonia as a fuel, and hydrogen just doesn't have the energy density to enable to move big ships around it. I don't see hydrogen happening, not to make a big dent in global shipping. So ammonia maybe is the answer there.
Interesting. Without giving away any trade secrets, can you share with us your work at E.ON and how that may apply in what we've been discussing today?
Yeah, so E.ON, E.ON's a global company that's looking to change people's lives really across Europe. And I'd say very much ammonia would be in the future tech box in E.ON. It's an interesting idea to look at, as and when a hydrogen economy develops. E.ON really is moving towards providing solutions to customers' problems. So it's not necessarily for E.ON about picking a technology winner, but actually helping customers navigate through what's a real complex patchwork of competing offerings to find the right solution for them. And that will be, for all of us, the big challenge of the energy transition is we're moving away from there being one or two simple answers to the energy conundrum to lots and lots of competing alternative options with different investment cases, different environmental cases. And as a company for E.ON to help customers transition through that and provide a solution that's right for them is really where E.ON is positioning.
And John, I'm curious to hear what the market and almost the competition looks like in this area. Do you get the impression that there are as many people trying to unlock the secret of ammonia as there are other alternative fuels, or is this more of a niche area that E.ON is pursuing?
No, I mean, as I said, E.ON is very much a long way off for E.ON. In terms of competition, I think what you see in this area is a number of companies who are looking at alternative fuels, and ammonia is, as I said, very much in the future tech box. So it's an interesting idea, but I think you need that hydrogen economy to develop first.
John, you're working on some interesting projects at E.ON. Can you share a few of these with the utility audience?
Yeah, so there's a couple actually that I think are really interesting at the moment, both around local energy systems. So E.ON is involved in a project called Simris, which is on an island off Sweden, and that's looking at balancing the supply from wind and solar against the local demand using an awful lot of technology, along with some batteries. And Simris is a really cool project. It's a really interesting research project. And another one is a project called Green Skies, which is in London. And Green Skies is looking at utilising waste heat from the underground railway line, underground rails, sewers, rivers, and using that to heat various buildings in London. And so E.ON are part of a consortium that's being led by South Bank University. And it's a really, really interesting project, which is also part of something called LOTNet, which is all about low temperature networks. And I think those are two of the really interesting local energy system projects that E.ON's involved in at the moment, and I'm hoping we'll see lots more of that type in the future.
John, I want to thank you for this informative and fun conversation.
Thank you, Jason. Thank you, Matt. It's been a real pleasure speaking to you both, and it is a privilege to be part of the Energy Central community.
If any of our listeners want to reach John, then you can do so through the Energy Central platform. I also want to thank our contributing partners of Energy Central, West Monroe. West Monroe works with the nation's largest utility-owned utilities in their telecommunication, grid modernization, and digital and workforce transformations. From defending a rate case to presenting a business case, West Monroe utilizes a multidisciplinary team that blends utility, operations, and technology expertise, covering topics like aging infrastructure, electric vehicles, AMI, MDM, and ADMS deployments and industry disruptors like DERs and cybersecurity. To ESRI. ESRI is an international supplier of geographic information, GIS software, web GIS, and geodatabase management applications. To Guidehouse, formerly Navigant, is a leading global provider of consulting services to the public and commercial markets with expertise in energy, sustainability, and infrastructure. And to CPower. At CPower, we help our customers make the decisions today that guide them across the bridge to energy's future. Where will your energy take you? For more information, visit cpower.com. Once again, I'm your host, Jason Price. Plug in and stay fully charged in the discussion by hopping into the community at energycentral.com. And see you next time at Energy Central's Power Perspectives podcast.